let's discuss power series. Hello everyone. First, let's define a power series. A power series is a function series of the form the sum from n equals 0 to infinity of a sub n times z minus a all to the n for some constants a0, a1, ... and a. Now, let's define the lim sup and the lim inf of a sequence. Suppose that a sub n is a sequence of positive real numbers. Then the lim sup of a sub n equals a if and only if a is the supremum of the set of all accumulation points of a sub n, i.e. the supremum of the set of all limits of the subsequences of a sub n. We define the lim inf of a sub n as the infimum of the set of all accumulation points of a sub n. Now let's discuss some results for lim sup and lim inf. If an is a sequence of reals such that the limit of an exists, then the lim sup of an equals the lim inf of an, which equals the limit of an. If b is greater than the lim sup of an and the set of all an is bounded, then all but finitely many points of an are less than b. Next, let's discuss some points on notation. If x is a subset of the real numbers and unbounded, then we write the supremum of x equals infinity. We may also write the lim sup of an equals infinity if the supremum for all a such that a is an accumulation point of a sub n is unbounded. Also, we denote 1 over 0 as infinity and 1 over infinity as 0, but this is just notation. Now, let's move on to DeMars Theorem. Let a1, a2, etc. be given complex numbers and define the number r by r equals 1 over the lim sup of the modulus of an all to the power 1 over n. Then, for any a complex number, the power series, the sum from n equals 0 to infinity of a sub n of z minus a to the n, converges absolutely for all z such that the modulus of z minus a is less than r, and the sum from n equals 0 to infinity of a sub n times z minus a all to the n converges uniformly on the disk that the modulus of z minus a is less than r for all r less than r. The sequence an times z minus a all to the n for n greater than or equal to 0 is unbounded for the modulus of z minus a greater than r. So, in particular, the series from n equals 0 to infinity of an times z minus a to the n is divergent. Note that r equals infinity is allowed here, where according to our notation, we set 1 over 0 to infinity and 1 over infinity to 0.
As ever, thank you for watching.